yet another question from an unknown version, unknown permutation of section 1 midterm, and it's one about KNN. I think these KNN algorithms are the simplest, but it turns out these questions are the most tricky ones. It's actually from one of the past exams as well, but I want to talk about it here. So the numbers are generated so that this k is always the sum of these two minus 1. The reason is because when we have k equals to n, then the KNN estimator is basically just the majority estimator. So we just predict everything using the majority. So let me actually show you that. So suppose these are positive ones, there are 29 of them, and these are negative ones, there are 13 of them. So suppose when we use the leave one out, it's called cross-validation. So suppose we leave the first one out, then we are going to use these 41 instances as training set to predict that last one, right? So we are going to figure out the 41 nearest neighbors. There are only 41 instances, so of course the 41 nearest neighbor are just these 41. So there are 29 of them positive and 13 of them negative. So if we ask them to vote, I mean, not 29, so 28 of them will vote for plus, and 13 of them will vote for minus. So that one for sure will be labeled plus. Actually, if you use the second one, it's the same idea. But even if you use the point here, so if you leave this one out, then you have 29 plus and 12 minus remaining, then still the majority is 29. So still they're going to vote for plus, so they're going to label this one plus as well. So no matter which one you leave out, that's the idea. No matter which one you leave out, you are always going to predict the majority, and the majority here is 29. So you are only going to leave these out. When you are leaving these out, you are going to predict them correctly. You are leaving these out, you are going to predict them incorrectly. So the accuracy should be 29 over the total, which is 42.